Hi everyone, this is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajalakshmi College of Arts and Science. In this series, we are discussed about artificial personality. So today we are going to discuss about human emotion model for robots. Here we are using emotion access and tagging for interaction. First, we see the introduction. A robot become more involved in human interaction, they must be able to recognize and respond appropriately to human emotions. Unlike traditional rule-based responses, an emotional aware robot can adjust its behavior based on how the human is feeling, making the interaction more natural and engaging. To achieve this, robot need an emotion model that helps them interpret human responses and modify the replies accordingly. A simplified approach to modeling human emotions in robotics involves using two primary axes. One is happy and sad, another one is distant. So first one is a happy and sad axis. This measures the emotional state of the human ranging from happiness to sadness. If the human expresses positive emotion, for example, smiling, enthusiastic tone or affirmative answers, the model shifts towards the happy side. Conversely, if the human shows negative emotions, example, frowning, a low tone or negative responses, the model shifts towards the sad side. Next one is a welcoming and distant. So this axis determines how open or closed the human is to interaction. If the human is actively engaged, giving detailed answer and showing interest, they are categorized as welcoming. However, if they are unresponsive, provide short answers, or avoid interaction, they are classified as distant. By tracking changes along these two axes, the robot can adjust the responses dynamically. For example, if the human is both sad and distant, the robot may adopt a more encouraging or empathic tone to re-engage them. On the other hand, if the human is happy and distant, welcoming, the robot can respond in a more interactive and engaging manner. Next, we see the emotion axis. Already we've seen the emotion axis are happy, sad axis and welcoming, distant axis. So the human-robot interaction, the ability to recognize and respond to emotion is crucial for creating meaningful and engaging communication. To achieve this, we use two-axis emotion model that helps robot interpret human emotions and adjust the responses dynamically. The happy sad axis, tracking emotional state. This axis represents the overall emotional state of the human. A person who expresses joy, enthusiasm, or positive feedback moves towards the happy side of the scale. Conversely, someone who appears frustrated, unresponsive, or negative moves towards the sad side. By monitoring this axis, the robot can determine whether the human is in positive or negative emotional state and tailoring these responses accordingly. For example, if the human is sad, the robot may use supportive and comforting language to uplift the mood. Next, we see the emotion tags in script. So, it responses from students can be in lecture setting, responses from student can be categorized based on emotion to help gauge engagement and sentiment. These following tags can be used for classification. First one is a happy. If a student responses is positive, enthusiastic or expresses satisfaction, it should be marked as happy. This can indicate that the student is enjoying the lecture or finding the content useful. Additionally, when such responses are received, the happy index should be increased to the track overall student sentiment. If a student expresses frustration, confusion, or dissatisfaction, the responses should be tagged as sad. This can signal areas where student may need additional clarification, supports, or adjustments in teaching methods. Next one is when students greet, introduce themselves, or engage in the initial conversation, the responses should be categorized as welcome. This helps create a friendly and inviting atmosphere in the class. So, fourth one is distant. If the student does not respond or remain disengaged, they should be tagged as distant. This could indicate a lack of interest, distraction, and or hesitation to participate. So, monitoring distant responses can help identifying students who might need engagement or a different approaches to boost engagement. By applying these emotional tags, instructor can better understanding students' reactions and adjust their teaching style accordingly. Increasing the happy index when positive responses are received allow for a measurable way to track students' engagement and overall classroom morale. Next one is a Python implementation. So in our approach, we use a dictionary to store and track emotional state dynamically. This allows us to monitor student engagement and sentiment through the lecture. So how it works? Dictionary for emotional states. We maintain a dictionary where each emotional tag, that is happy, sad, welcome, distant, has an associated index value. These index represent the frequency or intensity of responses falling into each category. Dynamic adjustment for indices. Every time a response is recorded, the corresponding emotional index is updated. Next, we see the neutral starting point. At the start of a lecture or interaction, the emotional state is said to be a neutral position, which can be true or thought of as the center of coordinate system with different emotion axes. A student's response, their engagement and sentiments in the emotional state dynamically and different directions. So neutral starting point. Initially, the emotional state is balanced with all indices set to a default neutral value. This ensures that no assumptions are made before the interaction begins. So emotional models are essential for enabling robots to adapt the human interaction in a meaningful and dynamic way. By using emotion access and tagging to classify responses, robots can interpret human emotions and generate appropriate reaction. A Python dictionary structure helps to manage emotional states by tracking and updating sentiments indexes in the real time. This allows robots to shift their behavior based on user engagement, ensuring a more natural, personalized, and human-like interactions. As emotion modeling advances, robots will become even more initiative, improving user experiences across various applications for customer services to education and companionship. We come to the end of this section. I hope you enjoyed this section. Thank you.